All right, so 4.3, we kind of have already covered the mechanics behind log functions, kind of what they look like, the domain, the range, that sort of a thing. We're going to focus today more algebraically. Now, what have I told you from the beginning? That logs and exponentials are what of each other? They're inverses, okay? That's going to be a really important thing for you to understand and to remember because we're about to start solving. And the way that you solve something is by using the inverse. So if you look at your calculator, there's a button on your calculator that says log, right? Does everybody see it? All right. And there's a button on your calculator that says ln. Does everyone see that one? All right. Log and ln are both logarithmic functions. Ln is a natural log. It's a very specific one. And then if you look above just above, like if you hit second log, you get this, 10 to the x. That's your exponential. They're on the same button because they are inverses of each other. What's above ln? E to the x. Remember, the reason that these are E and ln are specific, they get their own button, is because remember, E is programmed into your calculator. So whenever you see an E to the x, you think, oh, my inverse is ln. Whenever you see log, you think, oh, my inverse is exponential. But those are the two buttons on the calculator that we're going to use. Now, looking at these two, you should be able to visually see the difference between a log and an exponential. In a log, it says the word log. And in an exponential, you have an exponent where that is what? A variable. But the makeup of them is the same. In a log function, the base is the little tiny number. In an exponential function, the base is the big one. So I'm going to say to you guys, oh, the little base versus the big base. Now, what happens when you go from one form to the other? It's really simple. If you compare the two. If I start off in log and I go to exponential, I'm going to tell you guys, the little base becomes the big base, which is right there. And then what happens with x and y? They do what? They switch spots. If you're going from log to exponential, then whatever's on the right-hand side goes to the exponent. When you're going the other way, it goes from the exponent down to the bottom. All right, we're going to do a bunch of examples here. But again, you guys are going to be able to use your calculator for the solving part, but you need to understand the differences between logs and exponents. Generally, we think exponentially, and I'll show you what I mean by that in a second. All right. This is what I'm talking about. We think exponentially. If you look, the left-hand side is in log form. The exponential side is on the right-hand side. Left is log. Obviously, it says log. Exponential's on the right. If I were to rewrite this, if I was to write this to you guys, this problem is, you don't have to rewrite this. You can just look at it. And I said to you, what does x equal? A lot of you would be like, what? Now, you can do this in your calculator. You can't just hit the log button. I'm going to show you something that says change a base. I'll show you that tomorrow. But this is in logarithmic form. If you have to solve without using a calculator, and you don't know the change of base formula or anything like that, I'm going to tell you to think exponentially. So let's move this to exponential. If I was going to change this to exponential form, this is my little base. What does it become when I go from log to exponential? It becomes little or big? Big. Okay, it becomes big. I'm going to write it big. And then what happens with 8 and with x? They switch spots. If I'm going to exponential form, my x is going to go up here, and then my 8 goes on this side. Now, you guys know how to solve this. 2 to what power gives me 8? What does x equal? 3. X equals 3. We think better exponentially. That's when I say that, that's what I mean. If you have something like this, we're going to think a little bit here, okay? So I know you see the answer, but if I have log little 2 of 1/8, what does that equal? Well, let's think exponentially. If I was going to rewrite this exponentially, what does the little 2 become? Base. Big, the big base. And then what happens with 1/8 and x? They switch, so x comes up here, and I get 1/8. So we just did a problem where 2 to the x power equaled 8, and we got 3. What is the difference here? 2 to what power gives me 1/8? Okay, I like the thinking. I like your thinking. But what kind of an exponent gives me a fractional answer, a negative, right? This would be 2 to the negative third power equals 1 over 8. Because think about it. How would you make that negative 3 positive?
Bring it to the bottom.
You bring it to the bottom. It would be 1 over to the third, and that's where we get 1/8. So when you guys see negative exponents, I want you to think fraction, or vice versa. When you see a negative exponent, think fraction. If you see a fraction, think negative exponent. That's a good way to look at that. Now, another thing on your calculator, right? Your calculator says log, right? What's the little number in the bottom?
10.
It's a 10. Your calculator is in log base 10. If they just write the word log, you understand that there's a little 10 there. Any other time, it's going to be a different. So that's why, like, if you hit log, what was the question? If you hit log 8, do that in your calculator. Hit log 8. What do you get?
0.9.
Yeah, 0.8. It's not 3, right? A lot of people are like, well, I put it in my calculator because you put log base 10, not log base 2. So I'll show you, God bless you, I'll show you a change of base formula. Your calculators don't do it. It's a very simple conversion, no big deal. I'll show you that tomorrow. All right, let's scoot along here. Evaluating logs, all right? Some of you can see this in your mind, and it's pretty easy. I know yours looks a little different. I just wanted to show you. But whenever you have to evaluate and you don't have a calculator, I would tell you to rewrite it how? How do we think better? Exponentially. So I look at letter A, right? If I rewrite A, that little 10 becomes what? Big 10. And then what happens with 1,000 and the x? X goes to the exponent and then equals 1,000. So now this question is a lot easier. 10 to what power gives me 1,000? How many zeros do you see, guys?
3.
So 10 to what power gives you 1,000? 3. All right, if I look at B, log base 2 of 32 equals x. You guys are like, what? Rewrite that exponentially. You can see it better. What does the little 2 become? Big. And then what happens with x and 32? So 2, what this question really says is 2 to what power gives me 32? Yep, x equals 5. All right, the next one. My little 10 becomes big. And then what happens with 0.1 and x? Okay, so I'm going to rewrite 0.1 as 1 over 10. Right, 1/10. I see a fraction, so what do I think? Negative exponent. X is going to be what? -1. Very good, guys. I don't know why I wrote positive. Very good. -1. And then the last one. Rewrite D. 16. Okay, a big 16. What happens with... Okay, they switch. When they switch, I get 16 to what power equals 4, right? I know the answer's there, but let's think a little bit. How would you go from 16 to 4?
A fraction.
A fraction. Why are you saying a fraction? What's a fraction the same as?
Taking the square root.
Yep. If I said 16 to the 1/2 power, that's the same thing as saying the square root of 16. So x would be 1/2. A lot of people want to look at that and go, oh, you're going to divide. No, you don't want to, you're not going to divide there. It's not that you get a negative exponent to move it down. You have to think in terms of square roots when you get from a big base to a significantly smaller number like that. There's always a relationship, though. A lot of times you see 25 goes to 5. How would that happen? Half square root. What about 8 to 2? 1/3 the cube root. Good. Good. All right, good. All right, these are properties of logs right here. I'm going to look at this. You guys are like, what? And then I'm going to show you some examples. You're going to say, oh, can we have like 20 of these? If you have log little base 1 equals 0, that's saying, how do you raise A to what power to give you 1? What do you have to raise anything to give you 1? 0 power. What do you raise a to get it to equal 1? You know what? Let's not even look at this. Let me show you some examples. It's easier. All right, let's rewrite this exponentially so you guys can see it. Log little 5 1 equals 0. You guys are, huh? If I rewrote this exponentially, my little 5 becomes what? Big 5. What happens with 0 and 1? So 5 to the 0 power equals 1. Do you guys agree?
Yeah.
Anything to the 0 power equals what? 1. All right. Look over here at this one. First of all, what do you notice? What do you notice about log 5 of 5? Same number. Whenever you have log 5 or log 6 of 6, log 7 of 7, log 8 of 8, what's going to happen? They're going to cancel out, become 1. But if you rewrote this exponentially, this is 5. And then what happens with the 1 and the 5? They switch spots. 5 to the first power equals 5. Is that true? Yeah, for sure. So what do you notice here about this one? 5 with an exponent of log 5 to the what? What happens with 5 log 5? They cancel out, so your answer is just what? 12. Good. So if you have, whoops, scooting the wrong way. Again, you have log 5, little 5, and then a big 5. What are those two of each other? They're not the same numbers. Log and exponentials are what of each other? Inverses, opposites. So inverses do what? They cancel out. So this is just going to cancel out, and your answer is 8. So if you have a question like this, log 6 of 1 equals what? Some of you already know the answer, and some of you are like, oh, I'm not so sure. Rewrite it exponentially, right? We're trying to figure out what this is. So if I rewrite this exponentially, my 6 becomes big, and then what happens with x and 1? They switch spots. So x comes up here, and this becomes 1. So this is essentially saying 6 to what power is going to give me 1? You're going to tell me x equals what?
0.
Perfect. All right, look over here. Let's see. What do you notice? What's going to cancel? The log 9 of 9. So what's your answer? 4. What about here? The log 3 of 3 cancels. So what's your answer? Yep. What about here? Log 7 of 7. They're going to cancel out. What's your answer? 1. If you don't see that, if you're confused, I'm not sure, look at the difference between A and B. Rewrite it exponentially. I put a big 7, and then what happens with x and 7? They switch spots. So 7 to what power would give me 7? That's why x equals 1. Notice here, the little base and the big base are the same. Here, it's the little base and a 1. Nothing, no log anything is going to turn into 1 unless if it's 0. Okay, we went over this already. I'm going to do this quickly. What is the difference here between A and B? The negatives. What does a negative out in front mean? Where does your graph reflect? Over the x. Good. Reflect over x. It's going to go left to right. Where the negative is inside, where is your reflection? It's going to reflect over y. Actually, I said that backwards. I'm sorry. I mean, I said that right, but if it reflects over x, it goes from top to bottom or bottom to top. If it reflects over y, it goes left to right or right to left. Yep. All right. Now, I told you guys on your calculator, E and ln. Those are exponential and logarithmic functions. They're just special. So the properties that we just went over apply in the same way. If you hit in your calculator ln1, what does it tell you? 0. If you notice here, I have ln and e to the x. Those are inverses of each other, right? So they'll cancel out. Same thing here. E to the ln, they cancel out. Sometimes you have to use your calculator. Like you absolutely have to in C, but you don't have to sometimes as well. Look at A. What do you notice about ln and e? Those are what of each other? They're inverses. They're opposites, so they'll cross out, and that's why you get 8 equals 8. What did they do in this step to get to this step? Look at B. What did they do? Non-multiply both sides by ln. How did they rewrite 1 over e squared? They brought it up, right? So there was no denominator. Then you had ln and e right next to each other. That's why they cancel out. And the last one, there's nothing you can do, but in your calculator, hit ln of ln 5. What'd you get? Okay, you got that? Okay.
Did Louis Romano get to class?
No, ma'am.
Pardon?
All right, do these three in your calculator and we're done. What's the natural log of negative 2? What'd you guys get? Natural log of negative 2?
Error.
Error, okay. What's the natural log of negative 7? Error. What's the natural log of negative 24? What do you think it's going to be? Error. What are you guys noticing? Can you take the natural log or the log of a negative number? No, write that down. You cannot, very important, take the log or natural log of a negative number. That's going to come in handy when we go to solve. You get to the bottom of this big solving problem and you get the natural log of negative 4. And you put it in your calculator, it says error, and you're like, this problem doesn't work. Not the case. It just means there's what? No solution, right? Don't write error.